At the end of the last PowerPoint, I told you that I would just give you a PowerPoint uh, talking about combustion analysis and how to use it to determine. Combustion analysis is a tool to determine the empirical formula of a carbon compound like hydrocarbons, carbons that have carbon, hydrogen, oxygen, carbon, hydrogen, nitrogen, and oxygen. What we'll do is we'll use the products carbon dioxide and water and sometimes nitrogen to determine how much of each, the moles and grams of each element. And well, instead of me just trying to describe each step outside of a problem, what I'm going to do is I'm going to do three problems. One will be hydrocarbon, one would be a hydrocarbon with oxygen, and one will be a hydrocarbon with oxygen and nitrogen. So each one gets progressively a little bit harder. There's also one problem associated each one. So after I get done talking about problem, there will be a problem on the next slide, and it's for you to do. I'll send out the answers this weekend. You don't have to send me anything, okay? It's like doing a puzzle, right? And if you want to do it, do it. It's kind of fun. And I mean, once you, if you can figure this out, it's a good problem-solving type of problem, okay? Because you have to think about it. Okay, so let's get started. So the first problem says I have 1.5 grams of hydrocarbon. Now undergoes complete combustion and forms 4.4 grams of carbon dioxide and 2.7 grams of water. I want to find the empirical formula, which I call EF, and I also want to know the molecular formula given the molecular weight. Okay, so I know that this reaction will undergo is hydrocarbon right here, and combine with oxygen to form carbon dioxide and water. What we want to do is solve for x and y. Okay. So here we go. So the first thing you do is all of the carbon has to come from carbon dioxide. So here's carbon dioxide, has a carbon, and then that carbon started out here, okay? And all the water, all the hydrogens had to start out with, the H's and hydrogen had to start out with this H. So that's how you're going to do it. So if we can find out how many moles of CO2 are formed, we know that for every one carbon dioxide, there's one carbon, okay? Because carbon dioxide is made of a carbon and two oxygens. So let's do it. So all the carbon comes from carbon dioxide. So all this carbon right here comes from carbon dioxide. So what we're going to do is figure out how many moles that is, because we're going to find out the mole. So this X, it represents a molar ratio between X and Y. So it's easy to do that. I told you what we're going to do is to figure out moles now. We're just going to say divide by the molar mass. So I have 4.40 grams of carbon dioxide divided by 44, and I get 0.1 moles of CO2. Now, for every mole of CO2, there's just 1 mole of carbon, like I said here. So there's also 0.1 moles of carbon. So right now, this X equals 0.1. Okay, so here you could say X equals 0.1. Right, all the hydrogen comes from water. So what we want to do is find out how many moles. So we divide by moles of water. So we divide by 18, and it's 0.15 moles of water. Now for every water, there's 2 hydrogens. So we have to multiply 0.15 by 2 to get 0.3 hydrogens. Okay, so now what we know is Y equals 0.3. Okay, so this is X and this is Y. Okay, so now what we need is whole number ratio, because X and Y are whole numbers. And then just in previous video I said that you divide by the lowest whole number ratio, whole number value. I mean the whole lowest value, 0.1. And when you do that, you get 1 carbon and 3 hydrogens. So the empirical formula is C1H3. And the formula mass is 15 grams. So that's 12 plus 3 times 1. Okay, so that's what 50. Now to figure the molecular formula, we need to know the molar mass. And the molar mass is about 60 grams. And so the formula mass is 15. How many of those can go into 1 molar mass? And it's easy to find, there's 4. That means there are 4 empirical formulas in each molecular formula. Just like there's 4 formula masses in 1 molecular mass, there are 4 empirical formulas for 1 molecular formula. So what we do is we multiply the EF by 4 and we get C4H12. Okay, and you can check that. 4 times 12 is, you can see if it equals 60, it's 48 plus 12 is 60. Right, so the key thing is here is the carbon comes from, the carbon of this C comes from carbon dioxide. The hydrogen comes from water. All right, in the next example, we're going to add oxygen. So here's the problem. You give it a shot. Okay, and this one is just asking for the empirical formula, and it's a hydrocarbon, so you can do it all the same way. You're not given the molar mass, so you don't need to find the molecular formula. Okay, next problem. You have 95.4 grams of menthol. Menthol has oxygen, carbon, hydrogen, has a molar mass of 156 grams per mole. We combust it and it forms carbon dioxide and water. So here's the equation. Okay, and we know that, so this is what we're looking for. We're looking for X, Y, and W, and eventually we're going to want them as whole numbers. And these, we're going to find moles. X equals moles, Y moles, and W moles. Okay, so the first thing we'll do is find the amount of carbon, and the amount of carbon, X, comes from the carbon dioxide. So find the number of moles of carbon dioxide, and the way to do that, again, we're just going to make it simple, divide by the molar mass, and you get 6.11 moles of carbon dioxide. Okay, because there's 1 mole of 1 carbon per 1 carbon dioxide, there is also 6.1 moles of carbon. Now the other thing that we're going to need is also the mass of the carbon. So 6.11 moles of carbon is also 73.36 grams of carbon. Okay, and that's, you take the amount of moles times the molar mass. And we'll see why we do this when we get to this step right here, which is finding W. Okay, so we're finding X right now, and then Y, and then W. So, so right now, X equals 6.11. Okay, hydrogen comes from water. So what we're going to do is find the moles of water. So we divide 110 by 18, and we get 6.11 moles of water, which means there's twice as many hydrogens, because for every 1 water, there's 2 hydrogens. So what we do is we double the amount of moles. Let's say, like, if you have 1 person, there's 2 arms. If you have 4 persons, 4 people, it would be 8 arms, okay? Because there are 2 arms per person. So this is, instead of arms, there's 2 hydrogens per water. And so there's 12.22 moles of hydrogen. And then we're going to use the mass in a minute, okay? So that's easy to find. You just take the moles of hydrogen times the molar mass of hydrogen, which is 1 gram per mole. Okay, to find the amount of oxygen, okay, we don't have any direct source of it, but what we can do is we can look at is that the original sample, 95.4 grams, is carbon, hydrogen, oxygen. Well, we know the grams of the carbon and we know the grams of the hydrogen, so the rest of the mass has to be oxygen. Okay, so we simply subtract 73.36 the amount of carbon from the total mass, and subtract 12.22 from it, and you end up with 9.8 grams of oxygen. Okay, and then what you do is you find out the number of moles, and the number of moles you divide by the molar mass, and you get 0.611 moles of oxygen. Okay, so that's W. So what we have here is, this is X, this is Y, and this is W. These aren't whole numbers, so what we do is divide by the lowest amount, which is 0.611, and we get 10 moles of carbon, 20 moles of hydrogen, and 1 mole of oxygen. So the empirical formula is C10H20O. And when you add these up, say 10 times 12 is 120, plus 20 is 40, 156. So the formula mass is 156. Well, so is the molar mass. So it turns out, if they're the same, if the molar mass and the empirical, formula mass is the same, then the empirical formula and the molecular formula are the same. And here's the problem you give a shot. Okay, the last problem. This one's a little bit more complicated. We're going to add nitrogen to the mix. Okay, caffeine has carbon, hydrogen, oxygen, nitrogen. I have 1 gram of it. I'm going to combust it, and I get 1.813 grams of carbon dioxide, 0.4639 grams of water, and 0.288 4 grams of nitrogen. And the molar mass is somewhere between 150 to 200 grams. Okay, so this is what we have here. All right, so again, the carbon comes from carbon dioxide, so we divide, to find the number of moles of carbon dioxide, we divide 1.8183 by 44, and we get this many moles of carbon dioxide. Again, there's 1 mole of carbon for every carbon dioxide, so that's the same amount of moles. And we're going to need the grams, okay, because we're going to have to find oxygen, just like in the last problem, indirectly. And that's 0.4944, and you get that by multiply the moles by the molar mass of carbon 12, and you get this here. Okay, hydrogen comes from water, so what we do is find the number of moles of water by dividing by the molar mass, 0.0258 moles of water, and remember there's 2 moles of water for hydrogen for every water, so we double that to get the amount of moles of hydrogen. And to figure out the grams of hydrogen, you just multiply by the molar mass, which is 1. So 0.0516 times 1 is 0.0156 grams. So we have X and we have Y. Okay. Now Z, nitrogen, the nitrogen comes from N2. Okay. We know that nitrogen, there's 0.2885 grams divided by 28 grams per mole gives me this moles of nitrogen. For every nitrogen, every N2, there's 2 N's, okay? So don't let the word nitrogen get you mixed up here. When I say N2, I mean nitrogen, all right? So nitrogen gas. So for every mole of N2, there's 2 N's. So we have 0.0103 moles of N2, so that means there's twice as many N's. So there's 0.0206 moles of N. Again, we're going to need the grams, so we multiply that number, 0.0206, by 14, which is the molar mass of nitrogen, and you get this. Okay, so we have, so that's X, Y, and Z. Now, we don't have oxygen, but we have the total mass of the substance, 1. We have the amount of carbon, which is 0.4944. We have the amount of hydrogen, 0.0516, and the amount of hydrogen. So we subtract these 3, the grams of X, Y, and Z, from our 1 gram. And when we do that, we get 0.659 grams of oxygen. Okay. And then what we need to do is figure out how many moles that is by dividing by the molar mass, because moles is what counts in terms of the chemical formula. And we get this. Okay, so what we have is this is X, Y, Z, and W. Okay, so these aren't whole numbers, so what we want to do is divide by the smallest number, 0.0412. So we get one mole of carbon, 1.25 moles of hydrogen, 0.5 moles of nitrogen, 0.25 moles of oxygen. Okay, still not whole numbers, right? But it's simple to get them for whole numbers. If you notice, if you multiply them all by 4, you can get a whole number. And when you do that, you get 4 carbons. So multiply each one of these by 4. So you get 4 carbons, 5 hydrogens, 2 nitrogens, and 1 oxygen. Okay, so the empirical formula is C4H5N2O. And that has a mass of 97. Okay, now we're told the molar mass is somewhere between 150 to 200. Okay, we can see that 2 of these, okay, would be real close to 200 grams. So if we multiply the formula mass by 2, we'll get about 200. That means we have to multiply the empirical formula also by 2 to get the molecular formula C8H10N4O2. Okay, so that's it. Here's a problem to give a shot. And again, I'll send out answers to this probably by Sunday. Enjoy. This part of fun of chemistry is to do stuff without being graded. You know, it's problem solved. You figure it out. Okay.